Hey Calc, this is Mrs. Cometer. I am teaching from home today. I was planning on being back today, but then daycare closed, and so I'm staying home with my kiddos. So I'm going to go ahead and go through 9-1 notes just so we don't waste another day or miss another day. But um, there'll probably be some questions, especially from the non-trig kids. I'm going to pick on you guys this chapter. Not really pick on you, but um, you guys are going to be probably just slightly confused this chapter more so than the other kids who have had trig before because they've seen all this stuff. So I'm expecting you guys to have questions because you've never seen this. So um, Chapter 9, all about trig. 9-1 starts with radian and degree measure. So we have degrees. We know what degrees are. A full circle is 360 degrees, half a circle is 180 degrees, 90 degrees is a right angle. But then what is the equivalent of that in radians, which is the other measurement that we use in trig a lot? Okay, so they start us off by just giving us some vocabulary, I guess. Trigonometry is the measure of triangles. Angles are determined by rotating ray about its endpoint. And then it's really important when we talk about rotating an angle because we have something called an initial side, which is always going to be when you have something that's in standard position, you have your initial side that is on the positive x-axis, and then you're rotating the angle counterclockwise all the way around. So this guy might be your terminal side, and then your angle would be measured by this. This is probably going to be maybe like, I don't know, 70 or 80 degrees, because a right angle would be this right angle right here. Okay, we could rotate that around again and maybe put an angle over here. That would have to be greater than 180 degrees, which is just from here to here. So maybe that is 240 degrees or something like that. I don't know. And so we have an initial side, which is always on the positive x-axis. Your terminal side is where it stops, and then your angle is the measurement between them, and that's always when it's in standard position. So positive angle is generated by going counterclockwise. A negative angle is going clockwise. So if you have an angle that looks like this, maybe that is like negative 30 degrees, I don't know. Versus if it was here and it was the same measurement going this direction, that would be a positive 30 degrees because we're going counterclockwise versus clockwise, okay? So now, coterminal angles is one thing. One other thing. Layla, will you go open that door for her, please? What? Okay, go open that door for her, please. All right, so coterminal angles is basically angles that are kind of the same. So if I have my coordinate plane here and I have like 200 or 20 degrees, see I have this little angle right here that's 20 degrees, okay? If I would instead start here and I would go around one more time, one full circle is 360, so this would be 380 degrees, right? So 20 degrees and 380 degrees are going to look kind of like the same angle. They're going to have the same starting side, which is here, and the same ending side, which is here, right? 20 degrees is just from here to here, but if I go around one more time, that's 380 degrees. So we would say that 20 degrees and 380 degrees are coterminal angles, okay? So the same thing with 50 degrees and 410 degrees, because all I've done is I've added 360 to 50 degrees and I get 410. So those two both look exactly the same. These guys are in radians, radians, radians. So we'll talk about what 0 and 2 pi and pi over 2 and blah, 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 all that stuff looks like. Okay, so you know what coterminal angles are now. Definition of a radian. 1 radian is the measurement of a central angle that intercepts the arc S equal in length to the radius of the circle. Blah, blah, blah. What did that mean? Here's what this means. Whatever the radius is of my circle, and usually for the unit circle, that length is 1, okay? If I'm doing, if I'm looking at that being my radius of a length 1 radian would be the equivalent of this length being 1, whatever that angle is, okay? So my radius here has to be the same length as what the arc is here, and that many degrees that it opens up is what 1 radian is. Okay, so just to kind of put this into perspective for you, when we're doing arc length, that's a portion of the circumference. Circumference is the distance all the way around the circle. Hey, Layla, you're going to have to go in that other room, please. Or be quiet. Okay. So the distance all the way around the circle is the circumference. So we're really looking at this just portion of the circle. So a circle, his circumference is 2 pi r. Okay, circumference equals 2 pi r. And 2 pi r is equivalent to 360 degrees, right? One full circle around, all the way around, is 360. So that, we can set those two equivalent to each other. 360 is equal to 2 pi r. Now, what that means is that if we, let's see, if we're going 360 all the way around, the equivalent of that in radians is 2 pi. So from here all the way around is 2 pi, okay? So rather than it being 360 degrees anymore, in radians, a full circle would be 2 pi. Okay, so I'm going to draw this little map out here, and I'll show you kind of how this works. If I go all the way around the circle, this point right here is at 2 pi, okay? So if I'm only going half of the circle from here to here, that would just be 1 pi, okay? If I'm going just from here to here, like that 90-degree angle, that would be half of a pi, or they call it pi over 2. And if I'm going 3/4 of the way around, that would be 1.5 pi, or they call it 3 pi over 2, which reduces to 1.5 pi, okay? So those are my equivalent of radians. So rather than calling this guy 360 degrees for going all the way around, they'll call that 2 pi. So 360 is equivalent to 2 pi. 90 degrees is equivalent to pi over 2, because that's just from here to here. 180 degrees is equivalent to pi, and 3 pi over 2 is equivalent to 270 degrees. Okay, so those are the radians of each one of those corresponding degree measures. Okay, now, and rather than putting it as 2 pi, they a lot of times will write it in decimal versions. So 2 pi is the same thing as 6.28. Okay, so going kind of back to this diagram over here, 1 radius, this length right here, this guy is 1 also. There are 6.28 of those all the way around the circle. So this guy, from here to here, this guy has a length of 1. From here to here, this guy has a length of 1. And 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 same thing here. And then there's 0.28 from here to here. 0.28. So there's 6.28 radius lengths going all the way around the circle. Now, it doesn't necessarily have to be 1 though. This radius could be 5. That would also be 5. And this would be 5. And this would be 5. And there's 6.28 of those all the way around the circle. Regardless of what the radius measure is, there are 2 pi or 6.28 radius lengths going all the way around with the circle. Okay? All right, then they start talking to you about complementary versus supplementary. So here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. And complementary angles, they add up to be 90. So complementary add to 90 degrees. Supplementary is they add to be 180 degrees, okay? Now, I remember that because 90 comes before 180 and C comes before S in the alphabet. So some people get those switched around. C comes before S in the alphabet, 90 comes before 180 numerically. So that's how you can remember which one goes with which, okay? Now, instead of, though, calling it 90 degrees, we're going to give it the radian term of that. So 90 is equivalent to pi over 2, and 180 is equivalent to pi. So I would say that, like, let's say I'm dealing with like 60 degrees, okay? If I have 60 degrees and I want to know what his complement is to make 90, it would be 30 degrees, okay? Now, 60 degrees is the same thing as pi over 3, okay? Pi over 3, and I'm trying to figure out what I have to add to it to get pi over 2. And it is pi over 6. Pi over 3 plus pi over 6 will give you pi over 2. okay? And we'll go through that here on the back side. I think they ask you a complement supplement question, and I'll show you kind of how that works, okay? But we're going to be dealing with radians instead of degrees, okay? And you people who do not have trig are going to be super confused, and you're not going to know what the radian conversion is. But those of you who had trig might have it easier, because I hope you remember kind of what radians are, right? You can kind of remember that that's what the equivalents are. 2 pi is the same thing as 360, etc. So it's going to be easier for you guys to convert than the new ones. Don't get discouraged. Okay, let's go to the back side. So degree measure. Let me just go and do that example from the front. I thought they were going to ask a question about that, but I'm gonna stop and I'm gonna do an example from the front side. So let's say that I want the supplement, and I want the supplement of pi over 3. Let's do that. I know the complement of pi over 3 is pi over 2, because those add up to be pi, or the complement of pi over 3 is pi over 6, because those two add to be pi over 2. But how do I figure out the supplement, okay? The supplement says that pi over 3 plus something has to be equal to pi, because that's 180 degrees. Okay, so what I can do is I can just call this guy like x and solve for it and say subtract pi over 3 from both sides. Subtract pi over 3. Okay, that cancels, so I have x is equal to pi minus pi over 3. If I get a common denominator, this is like 3 pi over 3 minus pi over 3. So that would be 2 pi over 3. 2 pi over 3 is the supplement. Okay? So I already told you what the answer is for complement, but I'll show you how that works too. The complement of pi over 3, I said, was pi over 6. Okay, but we're going to show you why. Pi over 3 plus something, let's call it x, equals, and complement is 90 degrees, or pi over 2. So they have to add up to be 90 degrees. Okay? So I don't know what this x is, but I'm going to subtract pi over 3 to figure it out. Subtract pi over 3. Pi over 3. That guy cancels, so x is equal to whatever pi over 2 is minus pi over 3. Now I can only subtract them when they have a common denominator, so I'm going to go down here, and pi over 2 is the same thing as 3 pi over 6. And I'm going to subtract pi over 3 is the same thing as 2 pi over 6. 3 pi over 6 minus 2 pi over 6 is just pi over 6. Okay, and there is the complement of pi over 3. Supplement of pi over 3 was 2 pi over 3. Complement is pi over 6. Okay, so I know that was going through that really, really super fast, and if you have questions, rewind the video and kind of go through that a little bit slower, but that's kind of complement and supplement, how those two fit together. Okay, all right, so going back to the 2 pi being equal to 360 again, okay? 360 is equivalent to 2 pi radians, which means that if I divide both sides by 2, 180 is pi, right? We said that on the front side, where 180 degrees is half of a circle. So that's what pi is over there, okay? So when I'm trying to convert, I can say that 1 degree is the same thing as pi over 180 radians. If I divide those, if I divide this guy by 180, I get 1 degree equals pi over 180, okay? And if I'm trying to do radians, I can divide by pi over to this side, so I get 180 divided by pi is equal to 1 radian, okay? So those are the conversions between the two. It is only ever pi over 180 or 180 over pi. My circles are really bad. So I use those conversions to go back and forth. So if I want to know what like 135 degrees is in terms of radians, I can multiply by pi over 180 or 180 over pi. Now, here's how you remember which one to use. They're giving me 135 degrees, and I want to put it over 1. And we're going to use like the railroad track thingies, like what Mr. Muth does. And I'm going to set up something like this. These are called unit multipliers, by the way, if you want the technical term. So 135 degrees over 1, okay? Now, degrees, if he's on the top, I have to cancel with degrees that's on the bottom, okay? So I want, instead of using 180 over pi, I want to use pi over 180 because I need to have my degrees on the bottom, okay? So I'm going to put 180 on the bottom, pi on the top, and then that means that my degrees can cancel out here and here, okay? So then pi is going to be in my answer, right? Because most radians, unless they're in decimal version, are in units of pi, okay? So going back over here, we're just going to reduce the 135 and the 180, okay? If I think we can divide both of those by 4. Let me go to a different color. Girls, shh, just a couple more minutes. So if I divide both of those by 4, 135 divided by 4 is, no, wrong. I'm sorry, I'm going to divide both of those by 45. So dividing by 45, that's what I want, not 4, because that's what this is over here. Dividing both of those by 45, 135 divided by 45 is 3. 180 divided by 45 is 4. So 135 degrees is 3 pi over 4. It's like 3/4 of a pi. Okay, so there's that one, negative 270 degrees. If I put that over 1 times 180 is going to go on the bottom again because I want the degrees in the bottom to cancel with the degrees in the top. And I'm going to put pi up here. Okay, now just because it's negative doesn't change anything. Your just answer is going to be negative in the end. So 270 and 180, I can divide both of those by 90, I'm pretty sure. So 270 divided by 90 is 3, and I'm going to make him negative 3. And 180 divided by 90 is 2. So this equivalent is negative 3 pi over 2. Negative 3 pi over 2 is the equivalent of negative 270 degrees. Okay? Then this one over here is radians. Okay? So the pi is on the top. And in this case, I already have it as a fraction, so I'm just going to multiply by another fraction. If the pi is on the top here, I want the pi to be on the bottom here. So I'm going to use 180 over pi for this conversion because I want what's on top to cancel with what's on bottom. So the pi is going to cancel with the pi. And then I can reduce the 180 and the 2. So the 2, I can reduce both of them by 2, so this is 1. And this is 90, so I have 90 over 1, or just 90 degrees. And don't forget that there's a negative in front of this to start with. So I'm just going to slap the negative on the end of my answer, on the beginning of my answer. And negative 90 degrees is what that is. Okay. Now, number 4, they try to confuse you because they call it 2 radians over 1. 2 radians. So there is no pi and there's no decimals in here. But if they say 2 radians, that's just the decimal version of like pi over 2 or 2 pi or whatever. That's just a decimal. So rather than calling like 2 pi, calling it 2 pi, they'll call it like 6.28. Okay, so this 2 is just like the decimal version of something that contains pi. So in normal circumstances, if this wasn't a decimal, there would be a pi up here. So I'm going to put the pi down here at the bottom. Pi down here at the bottom, 180 is going to go at the top. And since this was a decimal to start with, I'm going to go ahead and leave my answer as a decimal. So this is going to be 360 over pi. And I'm going to go ahead and convert that to a decimal and get an answer. And I need my calculator. Just a second. Wait a second. And my calculator over here. Calculator. This is the handy dandy calculator that I had you guys download into your computers. So you can use it if you'd like. 360. Whoa. 360 divided by pi is that guy. And my answer is, this is equivalent to 100, and 14 point, let's do 6 degrees. 114.6 degrees is what 2 radians is, okay? So there's going to be on your homework a lot of converting. There's going to be some supplementary, complementary questions. So there's that. I'm going to wait to talk to you about angular and linear speed until Tuesday when I come back, because that gets a little bit more confusing, and I want to kind of be there to judge whether we're understanding this or not before I completely snow you with that stuff. But go ahead and start the homework. Do as much as you can with the conversions and that type of thing, and then I'll come back on Tuesday and do that. Someone will need to, well, never mind. So do as much as you can on the homework. I will post that on Google Classroom. Okay?